Hi, welcome back to the Object-Oriented Programming Simplified course. In this course, we relate object-oriented programming concept to real-world examples. If you are having difficulties working with OOP, that is Object-Oriented Programming, this is the course you should watch. In this tutorial, we will be discussing instantiation and initialization in object-oriented programming. In our previous example, the assignment was to create a registration form using object-oriented programming with fields for age and name. To understand the concept, we created a registration form in the real world containing age and name and HOD sign, submit, and print. The registration form is likened to the class in Python. You can check out the previous video for more explanations. We also created the Python code by creating a class called registration form and adding all the content of the form, which is the name, the age, the HOD sign. Let me add those here, the print, the submit, and HOD sign. As it is in the real world, the name, the age, the HOD sign, submit, and print are the attributes of the class, and you can also call them the class members. After creating the registration form class, we went ahead and added value to the name and the age. Comparing that to the real world example, this is like filling out the data on the original form, that is putting Martins right here. In the real world, this is not usually what is done. What you usually do is to create a copy of the form and then fill in Martin Davies in the copy of the original form. This is the original form. Original form should have nothing, and then right here in the Martins Davies form, we can now put in the Martins Davies information. In Python, we usually don't assign values into the class that we created. The class is like the original version of the form. So what we do is that we instantiate, that is, we make a copy of the form, and then we can start putting values in that copy, which is like making a Martins Davies example, and then we can start putting values in it. The original version in Python is called the class, while the duplicate copy is called the instance. The process of creating a copy from the original class is what we call instantiation. So let's wipe out this. I'm going to create a form I call Davies form, and I'm going to make a copy from the registration form. So you can see right here, I just made a copy from the registration form. I can also do Jane form, and then I'll create another copy of Jane form from the original form. So the original form stays empty because that is the form every other person will be taking theirs from, and then forms like Davies form will have the name Davies on it. So when you're filling the form, you're filling it on the form that is meant for Davies. That is, you are filling it on the instance and not on the class. Every time you create an instance of class registration form, you create a new object, or you can say a new instance of registration form is created. Let's take out this tree item and let's just have two. Let's take a look at initialization. When an object is created during instantiation, a special method is called in the class. The method is called the double underscore init method. It's double underscore init double underscore. Another way to call this is to say dunder init. So I'll be using the word dunder instead of double underscore. Dunder actually means double under, which is Python way of calling a double underscore init double underscore. So the method is dunder init, and it takes in the parameter self. I'm going to explain that later. I'm going to put pass here to indicate that it's an empty method. I'm going to remove it later. The self parameter is used in a class to represent or refer to the instance of the class. Technically, there are two types of attributes that are created when you create the instance of a class. The first attributes are attributes that are attached to the class. These are called the class attributes. The second attributes are attributes that are attached to the instance of the class, and these are the instance attributes. In the first example we showed you, to refer to the class attribute, we will say registration dot name, but to refer to an instance attribute, you're going to be saying self dot whatever attribute you have. If you have an attribute name here, it's going to be referring, you're going to be using self dot name. Okay, let's take this attribute out, the class attribute out. Let's use instance attribute. So to refer to instance attribute, you will say self dot name. So I can put these as none. Self dot age, none. In the real world, the name and age are also attached to the instance. So you create Davis registration form, and it's going to have the name and age attached to it. And when you create Jane registration form, it's going to have the name and age attribute attached to the Jane form. Let's put in another attribute here, a class attribute. I'm just going to call it num and initialize it to 0. We're going to see the difference and when we use the instance attributes or the class attributes. Right now, if you want to fill the form for Davis, the Davis form, you say Davis underscore form dot name. So we can say Davis Martins, and also Davis form dot age will be 45. If I have Jane underscore form dot name, that will be Janet Baker, and Jane form dot age can make that 22. We can do a printout of this form. I'm just going to say form 1 name age, so that will be Davis form dot name, Davis form dot age. So you can see right here the output is showing form 1 name is Davis form and age is 45. And when we do also for form 2, we can change the name. So Jane form name and age, you can see here form 2 is Janet Baker, age 22. So now they are separate. This is not like calling registration form dot name like we did the other time, which refers to the original form. This is a different form. This is like when you create the original form, you now create a copy, the Davis form, and then you fill in the name in the Davis form. We are able to create separate name and age because we created the dunder init method, and we said every self, that is every copy or every instance, should have a name and age, and that is why they have their name and age differently. Every time you instantiate the form, it initializes the form calling the init method, and it takes in a self that is referring to each copy of the instance, and in the process of initialization, it also stores the data, the name and the age data, in a dunder method called the dunder dict method. So if you really want to see the content of each of the instance, I can do Davis form and then use a dunder dict method Python provides the DunderDict method, and the DunderDict method shows you that Davis form has a name. This is the name you stored in there, and then age is 45. And of course, you can also do the DunderDict method for Jane. The DunderDict method, it's a dictionary that stores the attributes of the instance. So for Jane, you can see Jane has name, Janet Baker, age is 22. Let me comment these out and also show you that during initialization, we can take in parameters. Instead of writing Davis.name and taking in the values, we can actually do that during initialization. I can say put in the name and the age. I added the name and age parameter here, and I will say start whatever name I entered there in the name, and start whatever age I enter here in the age. If I want to now create the registration form, because of the init method that now has two parameters, actually there are three, but this first one is not going to be added. We're only going to be using the first and second, and we'll be putting it inside the bracket in the class. So I can put the name here. I'll say Martins, and the value 43. I can put name here Janet, value 33. So right now I am instantiating and initializing the name and the age variable. So let's uncomment this, and you see it shows name is Martins 43, Janet 33, and I don't need to do the initialization here anymore, because right here I initialized while I was instantiating. And of course, if you uncomment this, you would see that those values are in the DunderDict method of each of the instance.